chapter Chemical Reactions and Equations. This slide presents the overview of the chapter. Learning objectives. By the end of this chapter, you will be able to give examples of chemical reactions, represent a chemical reaction in terms of a chemical equation, balance a chemical equation, list the factors that make a chemical reaction informative, interpret a balanced chemical equation, describe the types of chemical reactions with their equations and examples. Explain about redox reactions with examples. Give examples of oxidation in daily life. List the methods of prevention of corrosion and rancidity. Introduction. Before entering into the chapter, follow the instructions shown on the screen. Click each tab to learn more. You know that various changes in nature can be classified into either physical or chemical. Physical changes are temporary in nature. The material undergoes change in its shape, phase, size, etc., but does not undergo any change in its nature. Chemical changes are permanent in nature. The substance present before the change does not exist by the end of the change, and a new substance is formed. A chemical change always involves a chemical reaction. The chemical reaction involves in our daily life situations. For example, coal is burnt, food gets digested in our body, iron nail is exposed to humid atmosphere for a long time. We respire. Milk is converted into curd. Water is added to quicklime. Crackers are burnt. But how to know that a chemical reaction took place? Let us try to answer this question and learn more about chemical reactions. Example 1 of chemical reaction. Click each tab to learn more. Take 1 gram of quicklime, calcium oxide in a beaker. Add 10 ml of water into the beaker. Touch the beaker during the reaction. Put a red litmus paper into the beaker after the reaction. The beaker is hot. A colorless solution is produced after the reaction. The red litmus paper turns blue. The beaker is hot during the reaction because heat is produced when quicklime reacts with water. The colorless solution produced at the end of the reaction is basic in nature as the red litmus paper turns blue. Now, let us do another activity to learn about chemical reactions. Now, let us do another activity to learn about chemical reactions. Click each tab to learn more. Take 100 ml of water in a beaker. Dissolve a small quantity of sodium sulfate, Na2SO4. Take 100 ml of water in another beaker. Dissolve a small quantity of barium chloride, BaCl2. There is a change in the color of the solutions in both the beakers. Add the solutions of both the beakers. Note the changes in the colors of the solution. Sodium sulfate reacts with barium chloride to give white precipitate barium sulfate. Sodium sulfate reacts with barium chloride to give white precipitate barium sulfate. Now, let us do another activity to learn about chemical reactions. Click each tab to learn more. Take a 3 cm long magnesium ribbon. Use a sandpaper to rub and clean the ribbon. Hold the ribbon using a pair of tongs. Burn the ribbon using a spirit lamp or a burner. A dazzling white flame is produced when the magnesium ribbon burns in oxygen. A white powder is formed and is collected in a watch glass. Here the two reactants, magnesium in solid state and oxygen in gaseous state, combine. A single product, magnesium oxide as white powder, is formed and collected in a watch glass. Magnesium powder is formed due to the reaction between magnesium and oxygen present in the air. Now let us learn about an example of chemical decomposition reaction. Now let us do another activity to learn about chemical reactions. Click each tab to learn more. Take a few zinc granules in a conical flask. Add 5 ml of dilute hydrochloric acid into the flask. Make a note. Be careful while handling the acid. There is a change in the color of the zinc granules. Bring a burning matchstick near the mouth of the conical flask. The matchstick is put off with a pop-up sound. The beaker is warm when touched with a finger. A chemical reaction involves in both breaking and formation of bonds, a change in the state of the substance, a change in the color of the substance, release of heat energy, formation of precipitates, liberation of a gas. After learning chemical reactions in details, let us now learn how to represent chemical reactions. Knowledge check. The description that addition of water to calcium oxide causes the formation of a colorless precipitate and release of heat, in only words, is quite long. A short description is calcium oxide plus water gives calcium hydroxide. This is a word equation. The substances which undergo the chemical change are called the reactants and are written on the left side of an arrow in the word equation. The substances which are formed after the chemical change are called the products and are written on the right side of the arrow in the word equation. Plus sign is used to add reactants and products in the word reaction. However, the shortest form of describing a chemical reaction with least number of words and symbols is called the chemical equation. A chemical equation precisely describes a chemical reaction in a compact form by using the chemical formulae of the reactants and products. The reactants and products are chemical compounds. The molecules of these compounds are made up of the atoms of individual elements. A chemical formula describes the chemical compounds in terms of the symbols of the constituent elements and subscripts to represent the number of atoms of each element in the compound. The formulae of calcium oxide, water, and the compound formed after reaction, calcium hydroxide, are shown. Replacing the words in the word equation with chemical formulae of the reactants and products, we have the chemical equation of the reaction of quicklime with water. Example: zinc metal reacts with dilute HCl to yield zinc chloride and liberates hydrogen gas. Example: sodium sulfate of reacts with barium chloride to give white precipitate barium sulfate. Chemical balancing. In a chemical reaction, an atom is the smallest particle of an element according for its mass. According to the principle of law of conservation of mass, mass can neither be created nor destroyed. That is, the mass of the reactants and the mass of the products before and after the chemical reaction should not change. It further means that the number of atoms of each element forming the reactants and the products should remain constant. In this way, application of the law of conservation of mass principle on chemical equations gives rise to the need for balancing chemical equations. Now let us learn how to balance a chemical equation. Systematic method of balancing a chemical equation. Click each tab to learn more. Step 1. Represent the reactants and products of the chemical reaction using their correct chemical formula. The unbalanced equation is shown on screen. Step 2. Tabulate the formula units in the equation. An atom, a molecule, or an ion in the chemical equation forming one unit on its own is a formula unit. Step 3. Place suitable coefficients before the formula units for comparing and balancing the number of atoms of each element on both sides. Make a note. The formula of reactants and product cannot be changed during the balancing of a chemical equation. Step 4. Check for equal number of atoms of an element on both sides of the equation using the table. Make a note. The coefficients should be reduced to their smallest whole number by dividing the equation throughout with the common divisor, if the need arises. Now let us apply these steps to balance an unbalanced chemical equation. Example 1 of balancing a chemical equation. Click each tab to learn the steps in detail. Propane C3H8 is a colorless gas with no smell. It is used as cooking fuel. It combines with oxygen to form carbon dioxide, water, heat and light. The balancing of the chemical equation of this reaction involves the following steps. Step 1. Represent the reactants and products of the chemical reaction using their correct chemical formula. The unbalanced equation is shown on screen. Step 2. Tabulate the formula units in the equation. Here carbon C, hydrogen H and oxygen O are the formula units. Step 3. For placing suitable coefficients before the formula units of the unbalanced equation. Place 3 as coefficient before CO2 on the right hand side to balance the carbon atoms on both sides. By placing 4 as coefficient before H2O on the right hand side, the hydrogen atoms in the equation can be balanced. To balance the leftover oxygen formula unit, we count the total number of oxygen atoms on the right hand side and find it as 10. The balancing of oxygen atoms is completed by adding 5 as coefficient before the O2 on the left hand side. Step 4. Check for equal number of atoms of an element on both sides of the equation using the table. Let us learn to balance another chemical equation. Example 2 of balancing a chemical equation. Click each tab to learn the steps in detail. Iron oxide or rust reacts with aluminium to form iron and aluminium trioxide. The balancing of the chemical equation of this reaction involves the following steps. Step 1. Represent the reactants and products of the chemical reaction using their correct chemical formula. The unbalanced equation is shown on screen. Step 2. Tabulate the formula units in the equation. Here, the formula of the elements iron, oxygen and aluminium Fe, O, Al respectively. Step 3. For placing suitable coefficients before the formula units of the unbalanced equation. Oxygen atoms are already found to be balanced on both sides. By placing 2 as coefficient before Fe on the right hand side, the iron atoms in the equation can be balanced. To balance the leftover aluminium formula unit, place 2 before Al on the left hand side. Step 4. Check for equal number of atoms of an element on both sides of the equation using the table. Now, let us learn about the factors that make a chemical reaction more informative. Now, let us learn about the factors that make a chemical reaction more informative. Click each tab to learn more. Expressing physical state. The state of the reactants and products as matter is more informative. Some of the notations used for expressing the physical states are S for solid, L for liquid, G for gases, and AQ for aqueous solution. For example, consider the equation on screen. The above equation provides us the information that iron oxide in solid state reacted with aluminium in solid state to form iron in liquid state and aluminium trioxide in solid state. The following characters of the reactants and products provide more information about a chemical reaction through its equation. Expressing heat changes. Heat is liberated in exothermic reactions and it is absorbed in endothermic reactions. The examples of these reactions are shown on screen. Expressing the gas evolved. An upward arrow is used to denote liberation of a gas in the chemical reaction. The example is provided on the screen. Expressing precipitate formed. A downward arrow is used to denote formation of a precipitate in the chemical reaction. The example is provided on the screen. Now, let us learn about interpretation of a balanced chemical equation. Interpreting a balanced chemical equation. Consider the following chemical equation. It tells that copper in solid state reacts with oxygen gas to form solid copper oxide. The formula of the reactants copper and oxygen are Cu and O2, and that of the product copper oxide is CuO. Here 2 moles of copper reacts with 1 mole of oxygen to form 2 moles of copper oxide. Interpreting a balanced chemical equation. A balanced chemical equation describes about the reactants and products through their symbols and formulae. It gives the ratio of molecule of reactants and products that participate in a chemical reaction. When molecular masses are expressed in unified masses U, then the relative masses of reactants and products are known from the balanced equation. When the masses are expressed in grams, then the molar ratios of reactants and products are known from the equation. If gases are involved in a chemical reaction, then we can equate their masses to their volumes and calculate the volumes of the liberated gases at a given condition of temperature and pressure by using molar mass and molar volume relationship. From the balanced chemical equation, the number of molecules and atoms of different substances can be calculated by using molar mass and Avogadro's number. The relative masses of reactants and products information is given by this equation. From the equation, we get the following relationships. They are mass relationship, mass volume relationship, volume relationship, mass volume, number of molecules relationship, etc. Numerical problem. Calculate the amount of aluminum required to get 1120 kg of iron by the above reaction.